Okay, hopefully you worked on these examples before you found this answer key video. Let's check it out, make certain we understand what they're giving us and what we need to do. So the directions say to evaluate. So here's my original function, f of x equals 2x squared minus 3x plus 2. The name of the function is f. They called it g, they could have called it h, they could have called it whatever they wanted. They use f. F stands for function. What's in this parenthesis following tells me what I'm supposed to find on the other side. Got it? This is not multiplication. It tells me the variable or the number I'm supposed to find on the other side where all those x's are. Good? Okay, so for example, number 1, f of negative 2. And I'm going to write it down here. So negative 2 is in place of the x, isn't it? And I'm talking about the function f, so I'm looking at the right one. So instead of saying 2 times x squared, I'm going to say 2 times negative 2 squared minus 3 times negative 2, because it's taking the place of x, plus 2. Yeah. Good? All right, because there's no x there. All right, what's negative 2 squared? 4. What's 4 times 2? 8. Okay, so this is 8. And then, good, plus 6. And then plus 2. Excellent. Okay. And when you add all those together, tell me what you get. 16. Good enough. So f of negative 2 equals 16. Lovely. Good? All right. So B. F of negative x. So the function f, and in place of the x, I'm supposed to put negative x. So 2 times negative x squared minus 3 times negative x plus 2. There's no x there. You ain't putting an x with that last 2. Got it? All right. So what's negative x squared? Yeah, well, you know negative times negative is positive. And since I don't know x, it's going to remain x, so it's a positive 2x squared. Good enough. Here, plus 3x plus 2. Can I combine anything? No. So f of negative x is equal to this polynomial. Got it? Not bad, right? Just have to recognize that whatever is in the parentheses is now taking the place of that x, which means it takes the place of the x's on the right side of the equal to sign. Okay, so let's look here. So 2 times, that's right, this whole quantity, x plus h squared, minus 3 times x plus h plus 2. Good. Okay, so I'm assuming you remember how to distribute. I'm just going to write the final result of doing x plus h times itself. And when you do this, please make certain you write the x plus h out twice and do your distribution. That's an h squared. Sorry about that. And then minus 3x minus 3h plus 2. And now I need to simplify. So f of x plus h is going to equal 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 2. I'm not really seeing anything I can combine together. Are you? Well, so be it. If that's what it is, that's what it is. Cool? All right. How about letter F? Plugging in the 4x for the h, or for the x. So 2 times 4x in parentheses, because you got to keep it together, squared, minus 3 times 4x and then plus 2. Good job, you guys. All right, so what is 4x, the quantity, the whole thing squared? 16x squared. Excellent. Minus 12x, I hear you, plus 2. One more line to simplify. What do you get? 32x squared minus 12x plus 2. Can I combine anything? Nope. Well, looks like I have a new polynomial there, don't I? So be it. Okay, letter E. Remember what I mentioned. This is a prelude to the difference quotient. So let's take a look at it. First, I need to know what f of x plus h is. Well, gratefully, letter C gave me that, didn't it? And that is rather long. So I'm going to kind of start it over here. I'm going to keep it in parentheses. So we have 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 2. That is f of x plus h. Good? Because that's what you got out of letter C, right? Okay. Minus f of x. Well, f of x is here. It's the original function. So we're subtracting off 2x squared minus 3x plus 2. Okay. Before I combine anything, I'm going to distribute that minus sign through, which means I do not need this parenthesis anymore since I'm doing a distribution. Because there's a positive here, so this is just going to be 2x squared plus 4xh plus 2h squared. Come on, say it with me. Don't make me say this by myself. Okay, minus 2x squared plus 3x minus 2. All right. Can I combine anything? Yeah, it looks like the 2x squareds are going to drop, right? Looks like the minus 3x and the positive 3x drop. Looks like the plus 2 and the minus 2 drop. So let's write what remains. 4xh plus 2h squared minus 3h. Excellent. So be it. Good? Okay. One more example. Hopefully you've already worked on it. And if you haven't, then go work on it. Example number 2 coming up. So here's example number 2. Hopefully you've already worked on it. Let's see if we agree with each other. So I notice my function is the cubed root of x cubed plus 1. Now, let me make certain we're both on the same page. This is addition in between the x cubed plus 1, correct? Can I look at these separately and take the cubed root of them individually? Some say yes, some say no. Here's how you decide. Addition and subtraction act like super glue. They just do. You can't pull anything apart, which means I cannot look at the x cubed apart from the 1, which means I cannot look at them individually to take the cubed root of each one. This is as simplified as f of x is going to get. It is the cubed root of x cubed plus 1. Good? Be careful of that addition and subtraction. Okay, so letter A. What are we going to do? You're going to plug in negative 2 for the x. So I've got the cubed root of negative 2 cubed plus 1. Well, what is negative 2 to the third? Negative 8. So I've got the cubed root of negative 8 plus 1. Yeah, that's the cubed root of negative 7. So, question. Do you know the cubed root of negative 7? Yeah, neither do I. But I do know something. When you take the cubed root of a negative number, the answer is going to be negative because I'm going to do some side work over here. Isn't this another way of writing the cubed root of -7 as a multiplication problem? As long as it's multiplication, I can look at them separately. And the cubed root of -1 is -1. So you get negative cubed root of 7 as your solution after you evaluate this function at -2. Good with that? Okay. Let's look at letter B. So you're plugging in -x. Got it. So it's going to be the cubed root of -x to the power of 3 plus 1. All right. Well, what's -x to the power of 3? You know it's going to be negative. And x cubed is still x cubed plus 1. So can I simplify that cubed root? Nope. You end up with the cubed root of -x cubed plus 1. All right, so be it. I'm not going to mess with it. How about letter C? Oh yeah, here's that long one, right? Okay, so we've got the cubed root x plus h cubed plus 1. Now, here's what I know. I'm going to have to write this thing out 3 times and distribute. And it's all going to be attached with addition, right? Which means I'm not going to be able to take the cubed root of them separately. So I really don't know why I should literally distribute that out, because I can't simplify it. And so if you're like, yeah, but letter E is going to need it. Okay, I get it. I personally would leave it like that, but this is what it looks like. And if you don't believe me, go pause the video and work it out yourself. Hold on, I need to think a second. Nope. Sorry, that's supposed to be a 3. Don't get too impressed. I just already know what it's going to be. Why? Because I've worked with it often enough. So, well, I can't take the cubed root of any of that individually, so there it is. Not so nice looking. Let's look at letter D. Cubed root of, in parentheses is 4x to the power of 3 plus 1. So what's 4x to the power of 3? You got to do the 4 cubed. What's 4 cubed? Stay off the calculators. Too late. You went on the calculator. That's okay. Okay, well, can I look at these separately? Nope, the addition sign won't let me do that. So there it is. Not much I can do. So be it. This is an interesting function, isn't it? Unless it's a number, it's not letting me do a whole lot. All right, letter E. Yeah, this is f of x plus h. I'm just going to write it this way. Cubed root of x plus h in parentheses cubed plus 1. And then I'm subtracting off the cubed root of x cubed plus 1. Now, as much as I would like to subtract, we need to remember addition and subtraction are picky. Things have to be exactly the same for me to add or subtract them. For instance, 5 square root of 2 minus 3 square root of 2. The square root of 2's are treated like a variable, so I can do 5 minus 3, which is 2, and then my variable is square root of 2. But these roots aren't exactly the same, and I can't look at them separately. I can't split this apart so I could do any kind of combining. This is letter E. This is all you can do. Cool? Makes sense? Okay. This last one was very interesting. If you need to rewind it and listen again, watch again, whatever you prefer, that's great. Work it out on your own again. That's great. You have fun with this, and I'll catch you on the flip side.